had to start with a fresh pot of water, so it took a while to boil, and it's very hot right now. So I'm going to bring it in here in like 2 minutes or 3 minutes when it is more carryable. I started trying to carry it and it was just so hot. And you really need to sit still for a minute or two to cool down. So, in the meantime, I'm going to start plugging away at this thing. Alright. Alright, so what we need to do is do something very similar to what happens here. All of that will be the same. This will still happen. Let me get the matching end temp. Okay, good. Get view relative mouse positions. Start from there. And create our UI list. Like that. Here's where things will change. I'm no longer going to iterate the buffers. I now want to iterate what's on my list. So that's going to look like this. Nope, bring me to the UI helper. Yeah. Alright, so our lister doesn't have its data in there yet, but we can fix that. Basically what we need is each of these needs a next prev to link it in. Really it just needs a next, right? I mean, this is a singly linked list. If we're going to iterate it in one direction every single time, unless you ever want to edit the list. Oh, come on. Alright, I'll just put the previous in there, as I always do. So we're going to iterate the list, and then for each step along the way, we're going to want to be able to see the string, the status, and the user data. Okay, so that's 1, 2, 3, 4, 5, 6, 7 times 8, 56 bytes per list string node. That's not horrible. I don't love it. If you had like 1,000 files, you're talking about 5 megabytes just to build the list, and then you trim down that 5 megabytes into the handful of items that are visible on the screen. Yeah, it's good enough. Okay. So there's our option node. Boom, boom, boom. Lister option list is just a lister option node. First, last, and then one little count. There we go. And then all we have to do is take the lister option node, lister options first, node does not equal 0, node equals node next. There we go. Now we are iterating the options. Let me pop this back over here and zoom in on this. So next what we want to do is deal with the filter. The filter will basically work like this. If state lister dot dot key string dot size equals 0, or if the node's string has the substring equal to the key string. There we go. And really, what I should do is this. No, I shouldn't do that. That's stupid. Okay. Yes, then we grab that. We grab that. We're grabbing the items. We don't need to figure out the status directly anymore. There's no need to push string copies on because we're not keeping this thing around permanently. All we need to do is push node status, node string, user data comes from the node's own user data. So the nodes that the user specified now are being connected into the item. The rest of this is all implicit in the fact that this is a lister. Yep. Item pointer, UI list add item. So that adds the item to my list. Good. Then we do this work. That's all the same. Good. We find out how many items there were afterwards. So now we have, now we have the ability to do an item counter and an int32 raw index counter. And the raw index counter is different just because it increments even when we filter out an option. We still increment the raw counter because it's about what order it's in the list. Okay, that's enough. I'm gonna go get my tea. It's been 7 minutes. It's definitely cool by now. Be right back. Yes, that's really going to do the trick. Although on a hot day like today, I wish I had the ice around to ice it. Oof, that would be better. Yeah. Anyway, I'm kind of feeling like just sort of manic, crazy man coding style is working for me right now, so I'm going to just keep going with it. Right, so what needs to happen here is that we want to set the query from the states lister query, and we want to set its string from the state lister text field. Ta-da! That works. That's a 0. Good. Activation level. Let me reorganize these to be in the right order though. Activation level coordinates. Coordinates activation level. There we go. Yeah, okay. And so then we add that item to our UI. Good. And then yeah, that's all correct. Boom, that's fine because that makes a copy there, so then we can clear the temp and we don't lose anything we need. Okay. Yeah. There we go. So The only thing we have to do that we didn't used to do is we need to set the raw index, raw item index or something like this, right? So the item index is just this thing. Whenever we find out what the highlighted item is, we also just want to set the state's raw item index to the raw item index counter, like SWO. Uh-oh. What did I get wrong? Right, so what we want to change that to is if the node's user data is equal to the state's hot user data, then that is the hot item. And we'll do and hot item does not equal 0, because if they happen to have two things with the same user data, I think the first one should be the one that takes precedent, not the last one. I should have scratched my nose before I came back on stream. I had the perfect opportunity to scratch my nose, and I didn't take advantage of it. Could have used tissue paper, get in there and really scrub it out. Okay. Anyway, so now we have everything working. Yeah. So our next trick is everywhere where it says rewrite, we now want to replace that with whatever the thing is I just wrote. What is that called? Lister update UI. Actually, that's list mode. List mode update UI. App scratch view state. Same signature modulo the function name. Alright. This is gone, so that's good. And now what? The other thing I wanted to worry about was the memory management. Basically, where I care about this is when I initiate the command and when the next command comes in that wants to reuse the existing state for a new purpose, right? Basically, for one thing, this scratch here is just bogus. I can't oh, you know what? That scratch is okay. The problem is more that when I call switch buffer, okay, activate switch buffer, we want right here, and yes, okay, I see. So these fellas should come and hang out lower down because they are slightly higher level layer, implementing two types of list generators. So they both generate listers. And then this right here wants to call that list generator. So boop, 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 boop. Please fill the state's lister with, okay, this is where we need to figure out the arena that we care about. That's where all the memory management happens, right there in that tiny little ploop, in that ploop right there. And I know how I want to do it now. I can see the whole thing. It's done. We're done. I mean, we figured this out. It's over with. Is there a default command to rename a file in 4coder? Yes. So without any customizations, Alt X to go into long command mode, rename file, and there you go. And that renames the file, closes the current buffer, and reopens the buffer on the new file name, so that the file on disk is changed and your buffer name will continue to save to that file. It will delete the original version, so this is not the same as a save as, where you keep the old name and the new name at the same time. Alright, I'm going to try to have more of this tea to see if it will calm me down a little bit. Ideal temperature right there. Okay. So, the last thing we have to deal with is, I just want to double check that I'm okay with this. The memory is going to sit around, being a pain in the ass, until it gets reused. It won't get freed. It could be freed if we get told that we're, if we're ending this state. If we know that we're ending the state, we can do something then. Okay, I know what to do. Alright. Cool. This will mean that it can't grow. If it doesn't have enough space, it just fails. How many bytes was this? 1, 2, 3, 4, 5, 6, 7 times 8, 56. Calculator. Suppose I took 1 meg, right? How many of these could I fit? 18,724. So if I took 1 megabyte, I don't know if I want to take that much. If we do it the other way around, what's the correct amount to be able to handle? If I just took half a kilobyte, that would be 900, or 9,000. It's quite a lot. You would need either 9,000 simultaneously open buffers, or 9,000 files in a thing, or 9,000 commands in 4coder, or 9,000 of something else. And I guess you do the same if you want reload a file command. I'm not sure what you mean on that one, Valbus. Do you mean like a file's already open and you just want to reload it? That's just Control-Shift-O. And be warned, when you Control-Shift-O, it's going to do this, because it automatically reloads the file before it even has a chance to finish the lexing, which means that it doesn't have the tokens available to do a proper virtual whitespace layout, and it won't redo the whitespace layout until you edit it to force it to do a new layout. And so you'll get that, if you're using virtual whitespace, you'll get that weird, like, everything is left justified all of a sudden. Okay. So the other option is to make this a growable memory situation. That would actually not be too hard to achieve in terms of making a thing we could allocate in free, but how would we build the arenas out of it on the fly is the real question. I think we'll go with this. We'll go with, I don't know, half a megabyte per view is still so much memory Suppose what I would naturally choose to do is 64K. Divide that by the 56, and that only gives you 1,000 items in your list. Of course, This is why I hate having to pre-allocate the memory, because there's no way to make everyone happy. If I just pass in an allocator that could grow, my arenas are bullshit. They don't do that. Okay, I know what I want to do instead. Not like this. We'll do it like this. That's what we'll do. And then this here can be the state's responsibility, not the lister's responsibility, which is nice. And it means that in the init list state, if the state's arena dot base does not equal 0, and so what we're actually going to need is a general memory right here. General memory free the base. And then the state's arena can become what you get when you make a partition by general memory allocating on the general memory arena size, make that 64K, arena size, okay, and then if we decide to end, then what we do is we can intentionally go, look, your base is 0, oh shit, we need the general memory, general, I'll stick that up here like that. We'll put you down right there. Here's the activate function. Yeah, user data should really come last. So here's the memory, the activate function, and the user data. There we go. So we have context shit and then input shit. And then what we can do is say, okay, then general if memory base does not equal 0, which it really shouldn't ever equal 0 in this case, then we can general memory free on the general memory, that memory base right there, and we can just go ahead and mem set that thing straight to 0. Okay. Good. 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 Yes. Now I just gotta figure out all the places where that causes compilation errors. Here they are. So, user data, you now come right here, and after app, we have global general memory, the view, and then the state's arena. Right. That's everything we really need. Boop. Wait, hold on, back that up. Boop. So we don't need that. For you, we need that. There we go. Boop. And then to init the list state, I have to pass in the global general. Okay, I think that's good. Okay, so everything should be working except for one last thing we have to do, which is we have to implement this and this. These won't be too hard. And then we should be able to run this thing. So how do we get the user data given an index? Well, we don't have an array, we have a linked list, so we have to iterate it. Ugh, I know. Maybe at some point we can do some optimization work. I say that every time. Alright, cool. So that will give us the user data of the nth node on request. And yeah, that's an O of n algorithm to do an index into a set, which is super lame, but it's also the easy way to make this work right now and gets called very infrequently. And to make it work quickly, what I would have to do is build some kind of baked down version of this list where the strings aren't intermixed, or where I'm storing an array of pointers. I could do the array of pointers somewhat easily, right? I would just do an array of pointers to these nodes. Once all the nodes had been added anyway. But the point is that that's easy to do some other time. Rasmus 0501, long day? I mean, it's gonna be when I'm done. This is gonna be a very long day. We're getting a shit ton done because 4coder has been, you know, sort of, it's like I took off the wheels, put it up on blocks, and I've been deconstructing the transmission on this engine for quite some time. I think that's a real reference to a car thing. I wouldn't know. Anyway, how do we add an item to this list? We push an array onto the arena. That array is an array of one node, and we store a pointer to that new node right there. That node gets a string from there, it gets a status from there. Huh. Okay. It gets a user data from right there, and then it gets DLL push zdll pushbacked onto the lister options first, lister options last node, with lister options count getting incremented by 1. Boom. Everything is done. Victory sip. Alright, let's open up a betting pool. The options are, it works the first time, it works after 1 bug fix, it works after 2 bug fixes, it works after etc. n bug fixes. Place your bets. I'll give you a minute. I'm placing my money on 1. We have Jim with 0 and the Big Foe with 1. Anyone else wanna? Rasmus has a bet on 0, so we have 2 zeros and 2 1s. Don't know if we have anyone else who cares to stake their reputation, however, you know, like 1/10% of their reputation on this. All right, I think. Well, I'm gonna wait till my tea is done to close the books. But I think we've seen all of our contestants. Oh, the big fox. I see. That makes more sense. Yeah, since you have a symmetric thing with the X's, I figured that was just decoration, right? I'm sure you understand the confusion already. Yeah, I messed up my screen name. That's why dimension is spelled with a T. So I'm no stranger to messed up screen names that you feel like you're stuck with for the rest of time. All right, one last sip on my tea, and then we will find out how this goes. 2 last sips. So I would have lost that wager. All right, how many bugs do we hit? Whoops. I'm so used to the Windows 10 thing where I can use my arrow keys to move around in this list now that I keep doing it. Let me build. This will come down to if I forgot to implement anything. Okay, that doesn't count as a bug, it was just a typo. Oh boy, Windows, always wrong. Okay, it's running. Okay, there's a bug. You see that? That's messed up. I'm not getting any text input at all. Clicking isn't working. Up down isn't working. Yeah, I don't know, that might be all one major bug mixing up everything, or we might have way more bugs than I thought. Rasmus asks, what's the motivation behind the rework of the infrastructure for the GUI? I assume you're talking about the rework of the GUI infrastructure that we're doing right now. The idea is to make the UI customizable. That's the main idea. Yeah, basically the idea is once I make the UI customizable, it'll be easy for me and other people to start kicking out cool features that are built on top of the UI system. But we used to just have this sort of dilapidated UI system sitting there in 4coder running a couple of important systems that it'd be great if we had access to it to do higher level stuff, but it just wasn't really set up that way. So I'm sort of exposing a new way to control the UI and getting everything moved over to that is a good way to feature test it to make sure that it is like if I had two different paths that both handled UI. The downside to that, the upside is we wouldn't have to go through this work of recreating the old stuff, but the downside would be that we would kind of end up in this situation where there's no way to really re-implement the file lister in the API because the file lister uses this one weird trick that isn't available to the lister, and so you're screwed if you wanted to do that kind of situation. And so to avoid there being this disparity between them, I'm implementing the old stuff on top of the new thing to make sure the new thing's at least feature complete enough to support that. And then I will try to implement new stuff that we've wanted for a while on top of it. And other people will be able to do that too once it comes out, because it's now customizable, as I said. Anyway, before I repeat myself again, let's find out what's going wrong. So, first of all, let's go ahead and... I got it. I already know what it is. Yeah, I can already do this. I can already do this in one fix. I'm sorry, I didn't rig this. I know what it is. Yeah. Okay, so that handles all of those. It leaves the user date of 0 because I don't need it myself. And the only other question is, what do I do about the query string? And the answer is, after I've initialized it, I just have to append Why don't I just do it this way? Oh, one thing I wanted to ask, are you going to include Casey's custom 4coder code in next releases? I couldn't find it anywhere. It's in the most recent release, I believe. Not sure when I made that change. I mean, I'll show you, it's right here. It's just like, it's amongst all the other 4coder code at this point. There's Miblo numbers, Casey.cpp. It's right there. I'm not sure if I made that change in 4.028 or if that's going to be coupled with this build, but it's in there one way or the other. Valbus asks, when will typedef keyword highlight like Casey has become a thing? Casey doesn't really have a thing that highlights his typedefs. What he did was he just used, well, he has access to the core, so he did this in a slightly different way. But you can just go, if you have access to the if you have the custom layer, you can make a copy of language CPP or edit it yourself and just put in keywords for the things you want. Like I could just go I32 token key type, right, and I can just load up all of my special types. And the thing is he doesn't have this for literally everything in his code base, but he has it for all of his basic, all of his like basic stuff. Like he wouldn't just have these. He would also go ahead and he doesn't call it arena, but in my code base it would be like arena and so on. All of the things that are like super common, right, would just get one of these, and so they would all get colored because he's just made he's manually made a list of the things he wants colored, and you can do that with your custom code too. If you want to know when will I actually do the dynamic version, not for a while. At least I needed a new engine because the old engine doesn't really handle. It doesn't really give me a way to do parsing in a dynamic enough way to do that. I need a new engine that would give me the option to write on the custom side all of the parsing logic, basically. Because having the parsing logic be internal was a big mistake that I made in the current engine. And it's a big mistake because it's just not possible to make a Lexer parser that's customizable enough to cover very many languages simultaneously. Like, to make it fully customizable, you basically have to have them submit to you the entire description of the grammar, and then from that, generate your parser, which is not the road I want to go down, right? So instead what I should have done, and what I will do in the new engine, is allow the custom side to be in charge of the parsing and highlighting, so that anything is possible that you can write code for, and then I won't feel so bad only supporting C++, because if someone complains, I can go, well, look, write it yourself, because here's how you can get started. Alright, the Big Fox says that the Casey code is available in 4.028. Good, that's what I thought. Oh, so all the language, any file with the name language in it, it's under the languages folder, and then language CPP has the one that defaults for CPP files, and there are a few other built-in like language keyword lists. So there's a keyword list for Rust, Java, and C# in there as well. But you can open up the C++ one, and you have a couple of options. You can either just make your own copy of this file and put stuff in there. You can edit it directly, but you'll have to make those same edits every time. Or you can make a file that is like, copy this into a separate file somewhere, right? Put that code in, and then define the extra keywords macro to the name of that file so that it gets included right here, and define that somewhere in your build line or in your customization code. Those are all ways you can inject keywords into this file, and yeah, it's up to you. You can also inject preprocessors if you for some reason want to. Like I know for JAI, for instance, this might be useful because their keywords basically can be either of these two types. So to support JAI, what you would do is you would, instead of making these preprocessor types, you would take these keywords and you would take the pound, the stuff that starts with pound that looks like a preprocessor, and just give it a type like key token key other, and then put that right here, and then list all the things that can be keywords with a pound in front. Jim asks, won't the dynamic version be much, much slower? So here's the reason it won't be. Basically, I mean, it has a lot. I put a lot of work into what the new engine looks like. It's not just a matter of shuffling the API around and doing lots of heavy callbacks and stuff. The new engine works in a way that allows me to heavily, to very aggressively optimize each stage of buffer processing in a way that I can't right now. So basically, let me just give you a little primer on some stuff about writing code. Sidetrack, we're not doing the day's work anymore. I think that the thing is going to work the next time I run it. I think I've made the changes I needed to make it work, so we're going to do something different. So here's what the buffer handling code looks like now, roughly. Alright, so there's sort of like a I think it's like buffer chunks. It's like this. Get buffer, get chunk count, buffer, push array onto the arena of buffer chunks, chunk count. It might not even be this sophisticated. I might just have a fixed width that's like, oh, 4, and assert that's big enough, right? In that case. In fact, I'm pretty sure I do. That's why I say that. So, buffer get chunks, buffer chunks, and then chunk index equals 0, chunk index is less than chunk count, chunk index plus equals 1. Okay. So what this does is this handles the fact that my buffer system isn't one contiguous array of characters, but is chunked up. So for the gap buffer, for instance, this is always 2, unless the gap is all the way on the left or right hand side of the buffer, in which case it drops down to 1 chunk. So that's the first layer of the loop. Then what do I do? Well, the next thing I have to do is do something like char index relative equals 0, char index relative is less than, and I probably get the buffer chunk right here. So here's the chunk I care about. Chunk equals chunks chunk index chunk dot count char index relative plus equals 1. So there we go. There's the second layer of our buffer processing. Now we are grabbing 1 byte at a time, And then what we really need is, before we start all of this work, what we're going to need to do is, because it's UTF-8, it's handling UTF-8, it needs to not necessarily treat each byte as something useful, because sometimes several bytes need to get glued together to find out what they mean, and sometimes we see several bytes that look good, and then there's a byte that says, that we look at and it goes, oh, we were looking for a 3-byte sequence, but the first 2 were good and the third one was garbage, so they're all garbage now. Treat them as garbage, right? Treat it as if we just saw 3 garbage in a row, but we didn't know that until we saw the third one, right? So what we also need is like a Unicode translator. And that can just be initialized like this because it doesn't need a dynamic amount of memory. It never needs to buffer more than 4 bytes at a time, I don't think. We'll just make this something like translator init, or make translator, right? And then we go, okay, good. So now what we want to do is go translator consume byte, and now we can go chunk dot text char index relative, and here's the translator, by the way, that you're going to need. Translator, okay. And what does it come out the other end? Well, it can emit anywhere between 0 and 4 code points. So I call this translation emit, or something like that. Emit. And then what I have to do, well, code point index equals 0. Code point index is less than emit.count. Code point index plus equals 1. Alright, great. So now we've done, what have we done so far? We've brought in one chunk at a time, iterated over each of those chunks. For each of those chunks, we've iterated over the output that we get when we we've stuffed 1 byte into the translator 1 byte at a time, and whenever it emits stuff, we then do a loop over the emits to handle that. So this isn't a this looks like it's a 3-dimensional loop, but that's actually not what it is, because really we're only iterating over one-dimensional input. We have a buffer of characters coming in, and we're handling them 1 at a time, right? That's the whole loop. It just looks this complicated already because we have to first deal with the fact that they're spread out over different chunks, then deal with the fact that as we read 1 byte at a time, those have to get stuffed into a Unicode translator, and then out the other end we get the thing we want to process. Now we can go, right? We've got a code point. Well, it depends on what we're actually doing at this point. So we've done this much work to get to a stream of code points from our buffer. What is the next thing we need to do? Well, if we're going to be lexing this code, we now want to start stuffing those code points into a lexer and have it emitting tokens that we store. But in more complicated scenarios, we already have those tokens, and what we end up doing is having a parallel, like, token stream type thing. By pulling out the tokens that have already been attached to that buffer somewhere. And so how does that get mixed in? Well, the token stream has to go something like, we want to figure out the relative index of each code point that we're looking at. So how is that possible? Well, the translator can keep track of how many code points it's emitted. So what we can do is say I32 code point absolute index equals code point index plus the translator's first index, something like this, right? Or the emits, that's what it would be. It's in the emit. So in addition to the emit having a count and enough space for several code points, it now also has another integer that tells us what the code point like which character, where character means counting each character as 1, even if it has more than 1 byte. And now we know where the code points start, right? And we can now do things like cursor seeking and stuff that converts between character indexes and byte indexes in the file, and so on and so on. But there could easily end up being anywhere between like 1 or 2 more loops of depth here, and possibly loops wide depending on what we're working on, right? And again, all of this is doing an ON style job because it's just doing however many bytes there are, however many elements there are in the input streams, it's just iterating all of those. So it could be like the number of bytes plus the number of tokens, right? But it's still a linear amount of work, and yet it looks this complicated. So this is actually really bad, and what's happening here is we have a number of transformations we're doing to a stream of data, and we're trying to say, as soon as we know what the next thing we would emit into that stream, we emit it and process that part of that stream in time right then, right? So we do a little bit of chunk processing, which doesn't take very much time at all. We do a little bit of byte processing until we can do a little bit of code point processing, until we can do a little bit of token processing, and maybe a little bit of rendering, right? And then we go back up here and do this. And what happens is, if you look at what this means, it looks like, oh, we've done a really good job like gluing this code together so that the slow version would have been to serialize the chunks into one contiguous array, right? So it's instead of being chunked, we could have imagined making this stream explicitly a loop over a real array, and then instead of emitting one code point and then processing that and pushing that into the next stage of processing, we would just keep on iterating over those bytes and emit all of the code points into an array. And we haven't done that, right? We haven't filled all those extra intermediate buffers. So this feels like it should be really good because we've tightened down the amount of work into this really single area where we don't have extra temporary buffers being filled and then read from to do these streams. We're doing them in real time as they come to us, right? But the problem is, if you look at what this actually looks like in terms of assembly, after a few layers of this, you have so many different iterator counters, and you count the results from each of these that you're overflowing your registers. So in assembly, what this looks like is maybe something like we have a chunk loop, and we have some kind of go-to chunk loop. I'm going to write basically C code that you can imagine as being very assembly-like. Alright, so there's our chunk loop, and how do we get the chunk loop to work? Well, we need to just set a chunk index equal to 0 right here, and down here we're going to take the chunk index and plus equals 1 to it, and then if the chunk index is still less than the chunk count, then we'll do this. Okay, great. Perfect. And now what do we do inside that? Well, we grab a buffer chunk. I have to put my variables up here so that we don't get into any like problems with skipping over declarations. Alright, so the chunk then comes from the chunks array, and we just put in the chunk index. Great, so now we have our chunk. Okay, and then we start a new loop. Okay, that's not a problem. We can translate that into some assembly like C as well. So that is more of a character loop. And so there we go. And if the character index relative is less than the chunks count, then go to the character loop again. Otherwise, we'll fall down to the outer loop and go to the next chunk. And so we're going to need that. That's the char index relative. That's good, that's good. And really what we're going to want to make sure we're doing is setting that to 0 every time we start the loop, because we are going to hit that loop several times. Alright, looking good. And if I keep translating this, the next thing that happens is, well, we have a call right here. Maybe we could unroll that call, but let's imagine that we just have to use this in so many places that unrolling the call everywhere is going to be kind of too much code duplication to maintain. So we don't unroll that. We have to make a call, and that call is going to look like this. Right? I can just copy paste most of that actually. You know where I'm going with this, right? You can see how to do this. Hopefully you can see how this translation is somewhat rote, so that you can imagine this code as assembly as I talk about the next part. Finally, let me get the code point indexes in there. Code point index, right? And so the code point index is equal to 0. And what happens, we have a code point loop right here. and the end of that code point loop, oh, this right here, we need a char index relative plus equals 1, and then the code point loop starts right there, and if the code point index is still less than the number of things we've emitted, then we go back to the code point loop again, and right here we take the code point index and we increment it by 1. And what's happening? Well, okay, there's another thing we're not doing quite yet, which is when we start one of these loops, like the character loop, we actually need to check that there are characters, right? Because what these loops actually do is check first and then run. So if character index relative is less than chunk.count, except we want to take the not of that expression now. So if that's not the case, then we're just going to go to the character loop done. And so we got to add a character loop done, which that happens right here, right? And let's see, starting to look somewhat hard to read. So code point loop done, and similarly, if code point index is less than emit count, except if that is not the case right at the beginning of the loop, then go ahead and skip straight to code point loop done. Okay, so there we go, and right, and then there's some, you know, more complicated work to do in here that involves more looping. I'll leave it at that. I think that is rich enough to explain the problem that I'm going to want to explain. Okay, so whatever happens in here might be fairly complicated. And let's imagine that we have available to us 16 registers. Okay, well, here's something to keep in mind. We already have one, well, the chunk is a struct. The chunk has in it what? It has a pointer and a count, so that's 2 registers right there probably. There's a third one for this counter here. There's a fourth one for the chunk, so there's like one, I can just count it right here. 1, 2, 3, 4, 5. The emit probably has, it's got a count. It's got, oh, it has to have that base index I was telling you about. So if there's 3 registers, 2, there's 5, 6, 7, 8. So 8 of our registers are just in maintaining this mega loop, right? And we don't need to keep them all in registers. If we want to, for instance, the chunk stuff might get flushed out to stack because we're not visiting the chunk stuff all the time. It's the stuff that gets visited less often, so somewhere along the line we save the chunk iterators to the stack, and that frees up registers to do other work. Great, except that every time you have to do that kind of save to stack, you know that you're doing a lot more work in, you're doing more work in a loop than you want to be doing. You want to make your loops, an ideal loop has the property that it fully saturates the registers without ever dumping anything to stack. Right, this is kind of like optimization, this is kind of like optimization, I don't want to put this, I don't want to say basics, it's more like the first sort of thing you start thinking about when you're optimizing is your register usage, is what I'm trying to get at. So, having this super mega loop has the advantage that in C code it looks like you've avoided nonsense that you don't want, like filling extra buffers, right? It's tighter looking. But in assembly, it's actually got much worse register usage than if you did the equivalent thing where you, for instance, maybe you did a chunk iteration and then for each of those chunks you stuffed bytes into a translator, but then instead of like taking the emitted things and looping then on them, you just stuff those into an output stream. So that instead of having this code point loop here that looks like this, at this point you stuff into an output stream, and so you can get you can then get this could be unrolled into a single thing here, and now you have a single call where you pass in some chunks, and it outputs a single stream of the code points that represent that chunks, and it's a full buffer of all of that. And we haven't even looked at how this wrecks the registers when we call this. So unrolling that, we might find that the rest of the 16 registers can be saturated pretty well in the code point translation stuff, and we now have one loop that iterates over chunks, the bytes in each chunk, and then turns those bytes into Unicode points and outputs them into a stream, and that's it. That's the entire stage of that process. And everything that we were going to do with those code points, we then instead do by iterating over the code point buffer, rather than trying to just in time grab one code point at a time and read them in that streaming fashion, which is actually just worse if you do it. If you do too many layers of depth on that, that's worse for performance, not better, even though your C intuition might be that it's better. And the reason that it's better to do it as separate passes is because at a certain point you're doing more like register thrashing than you would have to if you just did one full pass of. Right now the registers are fully concentrated on this transformation, and later the registers are fully focused on this transformation, and the only thing the only hit you take is that you have to write and read your input. You're writing your output from one stage and then reading it later, but that's one store and one load, as opposed to probably more than one load and store that you're doing on the stack if you keep thrashing the registers like that. So the point is, the current engine is written like this, and it's written like this because I didn't really understand all that. I've run experiments. I have a branch called 41x where I've run the experiments, and I can get 4coder to run many, many times faster by decomposing it into about a 4-stage transformation process to take from raw chunks of undecoded UTF-8 or UTF-16, translate them into pseudocode points that are marked up with extra information that I need for other parts of the other stages of the process, group them into words, and then color those words by pass those words through a phase that can be used customized, like a shader is a customizable portion of a pipeline like this one. And the user can then color words individually by reading through a token and word stream that is much more, it's not as granular as byte by byte. You get like, here's a word, there's a token, word and token, word and token, what do you want to do with these as you go? And that makes it a very small amount of data that you have to read in compared to the thing you would currently have to do, which is the entire fucking loop. You'd have to write yourself to customize this, basically, right? To change any of these things, you have to modify this entire mega loop at once in the current engine. In the new engine, these will run in separate stages. Now, this has all kinds of advantages. First of all, it runs much faster. It's also easier to customize and to slot in different transformations. So this right here is my UTF-8 translator. I can easily also write a UTF-16 translator, and now the rest of the pipeline doesn't get coupled like it does here. Right now, all the code that I write down here is coupled to an input type of UTF-8 or UTF-16, so if I write some really awesome code that does all the keyword detection stuff, but it's based on this thing up here that does UTF-8 input, I can't just take UTF-16 input and run with it. What I would have to do is take in UTF-16 input, convert it to UTF-8, and then go with it. But you don't really want to do that, because as soon as you've converted into UTF-8, you're then converting it out into UTF-32 for this process, right? So to avoid that extra waste, you want to find nice decompositions of stages of a pipeline for something like this. And this is the primary idea. I've laid this out in a blog post basically already, but that's the basic idea that the new engine will be based on, is that there are these recomposable pipeline stages that can take us from the raw buffer format to the fully marked up stuff with keyword highlighting, with white space, virtual white space, with like text alignment metrics for metadata, basically for skipping around in the file quickly and knowing the XY positions of everything. And because it's decomposed into multiple stages, I can optimize it way better, I can compose it more easily with more options, and I can make certain stages customizable very easily. That's the new engine. hope that that answers your question, Jim, so that you can see why I'm not too concerned about it actually being slower. I think it'll be faster even with the keyword customizations, actually. Valbless, I put the defines as you described with include file and recompile 4coder, but keyword is not highlighted. What I'm missing? I'm not sure. You'd have to send me an example of what your code looks like. You can define extra keywords either like in your, if you have like if you have your own, like this is the one I build, but wherever you've got your get bindings, before you include default include, you can just do define extra keywords equals my keyword header .h, and then you would have those keywords. The other thing you could do is you could go to build super and take a look and see this is .sh. I want build super bat. There we go. CL. Yeah, so right now I guess I didn't write this in a way. Source. Yeah, I didn't write this in a way where you can pass in another parameter, but I probably should have. But what I would do is I would just come in here and make a modified version of build super that takes like a /d extra keywords equals and then my keywords.h, something like that. Those are both options for you. And yeah, Jim, I put in 2017 I put in like half of my 4coder time was in researching how the new engine will if the new engine will be possible, basically. And I determined, I basically got 4coder working on the new engine mostly, except that I want to put a lot more work into it before I go ahead and release it as a new engine, because first of all, there's just there's so much work of optimizing that can be done once you have your code broken down into nice little kernels that don't have to do too much work all at once, and you allow yourself to fill a temporary buffer and then consume it and throw it away later, so that you're treating memory as a communication medium between stages of a pipeline, instead of doing what I was showing there, where you just build these monolithic, complicated structures. Once you're in that position, it makes optimization so much easier that it's hard to stop optimizing. So at some point I was working on it and I just stopped because I wasn't quite ready to invest like the 6 to 9 months that I think it's going to take to fully upgrade the engine. And I was still experimenting and stuff a lot, so I just stopped so that I could focus on finishing up this version. And once this version's finished up, I'm going to go incognito for like 3 to 6 months to get the core of the engine up and running as I just described it. And then when I come back, I'll spend a few more months 4coder Fridaying to get 4.10 out. And that new one will have to have a completely different API because of the fact that customizations will be very different for certain aspects on the new engine, like keywords and stuff, right? And along with that, I'll also be doing an API upgrade with that engine upgrade, so that I can just call it beta when I do that. Awesome. Valbus got it working. Sweet. Alright, so let's get back to this. So right, I think I got everything. We're setting the query now. We can get input from this, the default handlers. We have the activate switch buffer. Alright, we hit one bug. I'm going to see if we can work after we're fixing one bug. Okay. Okay, it says switch. I type in... Okay, typing still isn't working, so none of us were right. Click. Okay, click worked. Enter, up and up, down. Yeah, so enter is working. The only thing that doesn't appear to be working is typing. So let's track down why that is. Oh. I already know why that is. Yep, alright, it was 2 bugs, but I think... Yeah, I think that we can just go ahead and call this handled now, though, after I fix the second bug. So the other problem is a refresh problem. If I go to write character, what happens is we write a character and then we run this. No, that should work. I don't need to update the list. I just need to update the UI for the list. Why didn't that work? I actually don't understand. One last thought about that whole customizable keywords and is it faster or slower thing. The only reason to be worried is that if someone writes a slow customized like keyword detection system, it will be kind of easy to do that. Like I won't try to force you to be particularly optimal. Like I'm gonna try to make it so that that is the spot in the pipeline where there's the most forgiving performance curves, basically. Like I'm trying to give you a small amount of data to handle rather than a large amount, and I'm trying to make it the out memory management situation as trivial as possible and stuff like this, so that a lot of the hard work has been done for you, and literally all you have to do is say where you want wrapping to happen and what color you want to be placed on each token. The problem, and similarly with the Lexer, if you write your own custom Lexer stage, you're responsible for making it fast, and that part is concerning because users could easily slow it down there. But I think that that's sort of like a what can I do about that thing. To make something customizable, I can't really be forced to make sure that anything that they can write there is going to be fast. It's Turing complete. They can write slow stuff. There's not much I can do about that. It's on them if they write a slow Lexer and stick it into the pipeline. Oh, and the other nice thing is with that pipeline stuff, you can actually spin up multiple threads and handle. Right now, the only way to do multi-threading is each individual buffer gets handled on a different thread. But with that, you'll be able to load one file faster because it can handle it can do its stages of the different stages of the pipeline on different threads. So it can do like grab the first 8K of the file in text, translate that into Unicode code points, and then once that is done, it starts using the code points for the next stage while it grabs the next 8K of raw text for translation. And so we can get a sort of pipelining in the literal sense as well as in the architectural sense from that. Alright. So whatever is going wrong is befaffling me. Yeah, which basically means even without optimization, the new thing is like 4 times faster. Or, yeah. Well, it can't really be more than 4 because there's only 4 major stages. But yeah, anyway. I see the problem. What a lame reason to not get it on the second try. Alright, third try, here we go. It was 2 bugs. 2 bugs was the correct answer. There we go. Huzzah! How far are we into this stream? After that digression about optimizations in 4coder, yeah. So still an hour and 30 minutes into the stream, we have the switch buffer working. Let me try pull this up. Now I have to get the refresh stuff working because that we still don't have an answer for. As you saw, even though it had new files, it didn't know it had new files because I didn't refresh. Ooh. We've also lost the scrolling. Minor bugs. Okay. Scrolling still works, but the view doesn't scroll with the selection anymore. So we gotta fix that again. But I can click off this and I can type in bat and look at all my batch files. Come over here and look at all these. I can hit default hooks, and I'm looking at default hooks, and I can type, I can pop over here, and I can scroll around and hit that. Alright, so all of those things are working. Yeah, all of that is good. We need to track down these little issues. Definitely gonna rewatch that part. You mean the description of the 4coder, the 4coder off-topic stuff? Yeah, I was pretty excited when I started learning how to think problems through in that way. It's a game changer if you just allow yourself the freedom to break your problem down into small data transformations. Like, it's easy to think that you're breaking a problem down by saying, well, I have APIs to break this down. But APIs are kind of garbage by comparison to just data descriptions. If you say, like, we're transforming from this to this type, and that's where I'm going to put a boundary, I'm going to implement that transformation, and then I'll implement the transformation from that to this later, like, like 4 data types or 5 data types for 4 transformations. that kind of thinking makes it much, much easier to break a problem down than 4 APIs that can be implemented in with different implementations can do different things. That's actually much worse for composition in my experience now. And for optimization. I've been like, I don't know, veering more and more towards this idea of data formats as your API over called function signatures. Okay, so the problem I need to fix most critically is that I don't have the view scrolling anymore. Right, so the up-down stuff, set view vertical focus to item. Alright, somewhere along the way I accidentally deleted the thing that uses set view vertical focused item, so I'm going to go and see if I have that on Bitbucket still from the previous... Oh, I haven't necessarily pushed. I'm not sure. Let's take a look. Four-coder... Yeah, four-coder lists isn't here yet. Dang. Okay, I think I have a call for this, though, to make it easier. View set vertical focus. Yeah, okay. How did I lose that? It must have just been in here somewhere when I missed it. Set view vertical focus to item. There it is. Yeah, I just lost that somehow. Not sure where it was before, but hopefully it works from right here. App, view, Y top, Y bottom. Okay, so to get Y top, Y bottom, I need to look at the highlighted item. And now all I have to do is take the highlighted items, rectangle dot y0 and y1. Alright, so that's back to working. Cool. We're almost there. We almost have literally everything we want. The last thing is to think about refresh. Refresh is when we ask the whoever initialized this to call their generate all buffer lists again, right? We're basically saying, hey, will you please reinit the state from scratch? Lister. Yeah, okay, so we're going to want generate all buffers list. Going to want to clear the arena and then stuff the new shit on it, leaving that and that the same. Okay. So that's fine. That's not a complicated thing to do. Does the user want to implement that as a command? I don't think so. They want to implement that as a typed callback that receives the arena and receives the basically these three things, so that it can recall this, this from that, and this. Well, it doesn't really need to recall these, is what we're saying. It just is literally calling that. So, a function that takes an app pointer, an arena, and a lister is a function that we can call like generate list or something. Yeah. Okay. And okay, that's not going to be too bad. If I call lister begin, that clears all the shit. Which I guess I don't want. Or maybe I do, but the way I want lister to begin to work has just changed. I don't want it to do all that shit. Oh, shit. Okay, I want to keep that around. Someone has to do that, but that's not what this call will be for. This call is just going to memset the lister options, like so. Somewhere else we also need, like, I don't like list or init because I don't want users to call it I don't want users to call it thinking. I don't know. I don't want users to call it thinking it's an easy thing to think through. List or clear isn't very clear either, though. First init. That makes it sound more dangerous. Okay. Okay, so now the hardest part of all is figuring out when to call this refresh. I might work on that after a 5 to 10 minute break. Yeah. Alright, this has been a good one, folks. I will be back in just a little bit to figure out how to get this refresh working, and then we're going to implement the file open finally. That's getting done today no matter what. So, see you in a bit.